Today, I will be discussing the key material properties used in flexible pavement design according to AASHTO guidelines. These include the resilient modulus, California bearing ratio or CBR, Poisson's ratio, and layer stiffness. Each of these plays a critical role in determining pavement performance and service life. The first property is the resilient modulus, or MR. This is essentially the elastic modulus of pavement materials under repeated traffic loading. Unlike a static modulus, MR reflects how materials behave dynamically, simulating traffic conditions. In the AASHTO 1993 design guide, the subgrade resilient modulus is the primary input for calculating the pavement's structural number. In the more advanced mechanistic empirical design guide, resilient modulus is required for all pavement layers: subgrade, subbase, base, and asphalt. Typical values range from about 200,000 to 500,000 psi for asphalt, 20,000 to 40,000 psi for granular base, and 5,000 to 15,000 psi for subgrade soils. There is also a useful correlation. For fine-grained soils, MR in PSI is approximately 1,500 times the CBR value. The second property is the California bearing ratio, or CBR. This is an empirical test that measures soil strength by comparing its penetration resistance to that of a standard crushed rock. According to AASHTO, CBR is often used as an indirect method to estimate resilient modulus when direct testing isn't available, which makes it especially useful in areas without advanced testing facilities. CBR values typically range from 2 to 5% for weak soils such as clays and silts, and up to 20 to 50% for stronger soils like gravels and sands. Empirical correlations are used to convert these values. For fine-grained soils, MR equals about 1,500 times CBR, while for coarse-grained soils, MR is closer to 1,000 times CBR. Next, we have Poisson's ratio, which is the ratio of lateral strain to axial strain when a material is stressed. It describes how materials deform sideways when compressed or stretched. In AASHTO's mechanistic empirical design approach, Poisson's ratio is required for stress-strain analysis using layered elastic theory. It influences two critical calculations: tensile strain at the bottom of the asphalt layer, which is linked to fatigue, and vertical compressive strain on the subgrade, which is linked to rutting. Typical values are 0.35 to 0.45 for asphalt, 0.20 to 0.40 for granular bases and subbases, and 0.40 to 0.45 for subgrade soils. Finally, let's look at layer stiffness, which refers to the elastic modulus of each pavement layer. This property determines how well the layers resist deformation and distribute loads. In the AASHTO 1993 guide, stiffness is represented by layer coefficients, which contribute to the overall structural number of a pavement section. In the mechanistic empirical guide, stiffness values are used directly in stress-strain calculations. Typical values are 2,000 to 5,000 MPa for asphalt, 200 to 400 MPa for crushed stone base, 100 to 250 MPa for granular subbase, and 35 to 150 MPa for subgrade soils. In summary, these material properties, resilient modulus, CBR, Poisson's ratio, and layer stiffness, form the foundation of pavement design in AASHTO methods. They determine how pavements respond to traffic loading and environmental stresses, ultimately influencing both performance and lifespan.